Yo, folks, what's up? Can everyone hear me? Can everyone hear me? Can everyone see me? Hello, good evening. Greetings to all you wonderful people. Please let me know if the music is audible or not, or whether it's too loud, because yesterday when I interviewed Matt Miller, this was the first time I streamed on my new desktop, so I haven't really played with the backing music and all that sort of stuff, so I just thought I played around with it a little bit just before kicking off to make sure things sounded good. But yeah, better to make sure that you guys... Yeah, I am very pink. Don't know why that's the case. I need to fix the lighting in here, so... But in a minute when I flip over to the VMware scene, it won't matter anyway because I'll be doused in blue. So maybe I'm actually very pink and I just didn't really know it. Half grey, half pink. I need to figure out the Chrome key thing a little bit more as well. But hey, it serves its purpose. You get to see my emotions. So thanks to everyone who came along last night and enjoyed Matt Miller's interview. I had a ball. It was certainly a lot of fun. I know that, dude. I know I'm old. There was someone asked the question yesterday why I wasn't drinking tea on stream, and I didn't answer that. And so the answer to that is officially it was really, really late, and that's why I didn't want any more caffeine in the blood. So I didn't have any more. MXD said it was great to hear those stories. Yeah, how good was it? Matt was really great to talk to, and I don't really get nervous that often, but talking to someone like him, it was nerve-wracking, But the guy was really great fun, so it came off really well, and the feedback's been really great, and Matt really enjoyed himself. So maybe we could do that a little bit more. I have requests for 3 other people at the moment. I'm pretty sure that 2 of them will say yes. One of them may be tentative, but we'll see. We'll see how we go. So anyway, grab your tea. Hacking without tea is very uncivilized. Go Kuro tonight, back on the green again. Oh, so good. So very, very good. Right, now, I don't know whether you guys remember, but where we left off isn't exactly what you're going to be seeing on screen here. And the reason for that is because I had to move my VMs over to the new desktop. And so IP addresses have changed and I had to shut them down and all of that other wonderful stuff. And so what's on screen here isn't exactly the same, but it should at least serve the purpose for carrying on. Just assume that what you're seeing is pretty much bang on what you were seeing before. Okay. Now, last time we left, when we finished up, we were trying to run this piece of code here, and we were finding that we didn't have the length of the payload being sent down the wire. So let's make sure that we can actually get to the same spot. Just building again. So connecting back, we end up reading down the full stage size, and remember, look how big it is. So it's clearly not right. What we can see here in our hex is MZ. So that's our MZ header. So I couldn't figure out why that was the case when we were on stream the other day, and 3 minutes or so afterwards, yep, lo and behold, the answer came to me. But being a good boy, I decided not to do that off to the side without everyone watching. So I had to force myself to wait until now. So, do you remember when we implemented this MSF core payload CLR.RB, which is this puppy here, we stripped out a bunch of stuff because we don't really need it. But there's one thing we stripped out that we do need. So if we scroll down here, we'll see, where are we? So this handle intermediate stage. Now we don't have an intermediate stage, but we still have to handle it, right? If you have a look at this, if the stager does not require a mid stager, then boom, see that? Con.put payload .length packed. Very simple as that. Hey Peleus, thanks for coming, buddy. So yeah, I looked at that and I remembered this and thought, oh, that's right. Even though you don't have a mid-stager, the responsibility of the mid-stager is at least to begin the staging process of the final stage. So, hey, Brent Cook's here too. Welcome back, mate. Nice to see you again. So this is the magic piece of code that we're missing. All right, so I'm just going to take this. I'm just going to drop it in here. So I'm going to need, going to need another end in here. Now, I'm not going to do any if checks. I'm just going to return false like we did before and leave all of this pretty much exactly the same. So at this point, all we're doing, maybe I should write some comments. We don't have intermediate stages for the CLR payloads. So we are just going to return the length of the full stage. That makes sense? In hindsight, Peleus, that did come across that way, and I certainly don't mean that to be the case. Please accept my apologies, mate. I'm always happy to see you, you know that. So this function is called in a bunch of different scenarios. So let me show you. Handle intermediate stage. So you can see there's a bunch of overloads, but the call is in, where is it? Def. There's an invocation. Here we go. So payload stager. So if we edit lib msf core payload stager, then we should see it, right? Oops. Here it is. So that's where it's called. As part, when a connection first comes in, it does some magic, and then it says handle intermediate stage. And from there you can see it just says if we don't handle it, then do this particular case. So this is where our stuff needed to get wired in. Okay, so fire off MSF console again. And let's give it a test. Now I'm excited because I think we're going to start seeing some cool stuff here. Righto, so fire up our debugger. Skip over, and we are actually going to get a proper size. There you go, 7443. How cool is that? So if we read that in, and then we read in the entire stage. Now we skip over the MZ header in this reader, remember? We skip over the MZ header because we know we've packed 4 bytes, which represent the basically the offset to the configuration block. And here we go. Let's see what happens here. So the metserv size is 7,000 hex bytes, which is rather round, but hey, let's see what happens. So we'll skip to that, and we're going to do pass. Remember, full stage is the array that contains the whole metserv DLL and the configuration block. We're just going to see if that actually works, and then after that we'll pass in the memory reader that points directly to the config block to see if that works. Here we go, assembly. Look at that. Interesting. So the assembly, metserv.net35, looks like it's loaded. Manifest module is metserv.net DLL. Let's see what happens. Hey Mongo, welcome back, mate. Can we get the type out of that assembly? Yep. And can we invoke it? Looks like we can. Let's see if this actually loads our config and everything. So our current transport is TCP transport with is connected set to false. But that's okay because we are setting it here and then running. Okay, so at this point, we have a session. We have an expiry, we have session GUIDs, we have one transport with the configuration set to TCP. So by the looks, things are going pretty good. So there's one thing that I want to change though. Oh, you did? Notifications? That's a bit strange. Savio, no. So assemblies in .NET MSIL, they are a Microsoft's intermediate language. That's bytecode. It's kind of like Java bytecode, but for the CLR. So that's what this is. It doesn't really have a CPU because the CLR can be both x86 and x64. So if you see at the top here where this build configuration is, up here, any CPU. See what I mean? You actually build for any CPU. Yeah, you send a DLL, but that DLL can be loaded into both 32 and 64-bit processors. So there's CLR magic that goes on behind the scenes to make that all work. So what I want to do with this program, though, is this. See how we've got a project reference? I want to make sure that nothing in here is referencing that. Oh, what am I doing? Not that. I want to get rid of it from here, right? So let's get rid of these. I just want to make sure that in doing our current testing, that there's literally no reference at all, no instance of that assembly in memory. So we know that we are actually loading it from a byte stream. Okay. Here we go. Assembly.load full stage. Did work. Type comes out. Look at that. Does actually work. Ooh, what happened here? It's because I stepped over something, eh? Let's just quickly run over that again. And we'll see. We just want to test and validate that what we're doing makes sense. So run. We wrap the TCP client. Let's see where we broke. Is it connected? Yes, it is. Here we go. This.currentTransport.getPacket. Throw not implemented exception. Well, that would be why, wouldn't it? Hey, fantastic. Does metserve DLL send through Y already has type? Yes. So we know for sure that our server type, the thing that we're bootstrapping from, which is here, is the type met.core.server, and we pull these bootstrap methods, which are static, and invoke them directly using reflection. And that's what gives our stager the ability to invoke this without actually knowing anything about the type as far at compile time. Hopefully that makes sense. Anyway. So we are definitely creating sessions now as far as the Metasploit side is concerned. So I'm pretty excited by that. A couple of things I think we just need to quickly change. Transport config. This was brought to my attention by Ronan. This needs to be set to URL size because we created this constant up here for a reason. And another thing that I'm going to do now that we're actually using URIs is, see how we've got this URL.split? We don't actually need to use that anymore. We can go this.uri.scheme. I think it's scheme. There we go. So the URI will have the scheme in it, and that should do exactly what we wanted. So you know DLL exported functions, and you design the new CLR namespaces accordingly. Yeah, so we chose in the earlier part of our streaming, we decided to call this the Met for Meterpreter rather than calling it Meterpreter, making it stand out. This is the core component or the server component, so to speak. So we again collectively decided on core for this particular piece, and the server is the thing that runs. So we want to create an instance of a met.core.server, but rather than sort of invoking constructors through reflection, we decided it would be better to use static methods. So if we look here, you can see we just load the thing in bytes. We then get a reference to met.core.server, which gives us the type of this class. And then off that, we look for a member called Bootstrap. We see it's a public method, it's static, and we want to invoke it. So here, see how we're going type.invoke member. So we want to invoke it. We're passing in a couple of things that don't matter at this point. And then the last things we pass in are 2 arguments. And so those 2 arguments will map directly to these 2 arguments here. Now, having this Bootstrap available in this manner means that in cases where we have a TCP connection, we can actually pass that in and reuse it. In cases where we don't have TCP, we might be using HTTP, for example, then we just pass in the reader and off it goes. And from there, the configuration is read and everyone's a winner. So does that make sense? I hope it does. Okay, so that's pretty cool. What we now need to do is start reading packets. And this is where things are probably going to get a little bit more fun. We're going to leave this stuff here for now, but let's go back to our TCP transport because we do need to be able to read a packet off the wire. Okay. Now, in order to read a packet, we need to do some very basic stuff. But what I think we should do is effectively, if we look at what we did with our, where is it? It's under proto, isn't it? Packet. So a packet can effectively read itself off the wire, remember? So where are we? To raw and packet create response, packet add to string parse data. So how did we, oh, we did this in our test program, didn't we? So let's have a look at what we did here. So that's testing the configuration. So we can just create a new packet and give it a blob of bytes. Now we don't actually have a blob of bytes. So maybe what we need to do is do exactly the same thing, but give it a stream and see what happens. Now the question there is that going to cause us any problems? Probably not. So how about we do this? We go public packet binary reader, and we will wrap it in a binary reader on the fly. And so again, we want to invoke the overload to make sure that our TLV dictionary is prepared. And from here, we basically want to read. We know that we need to read. So we've got XOR key first, which is 4 bytes, right? Remember that. Then we've got the what is it? The session GUID. Yeah, I think that we've got the session GUID. Then we have the encryption flags. Session GUID is 16 bytes. Encryption flags, that's currently 4 bytes. Then we have the length of the packet, 4 bytes, and the type of the packet, which is 4 bytes, right? Can you explain the overload part? Absolutely. So the general idea behind an overloaded function means that the parameters to the function that you're invoking are different. So if we have a look at this other example, which looks a little bit clearer under server, you'll see that we've got a method called Bootstrap. If I can find it. Double O, that's my problem. Bootstrap. So you see we've declared one method here called Bootstrap. And Bootstrap takes 2 parameters. Binary reader and a TCP client. Okay? You'll also notice that there's another method with exactly the same name. And it only takes 1 parameter. Okay? So what this means is we have 2 functions with the same name, but they are overloaded based on the argument list that we give them. So as long as the argument lists are different, we can continue to add overloads. So for example, I could go public static void bootstrap and just take no parameters, and that would be fine. Okay, you see how there's no error. But if I decided, you know what, I want to do another implementation that takes a binary reader, you'll see that the compiler complains about the fact that we've got a duplicated method. Okay? So what this means over here is when it comes to the packet, you'll see that we've got a packet constructor that takes a block of bytes. And that one is public, so you're able to invoke it from the outside. This actually calls the private constructor that has no parameters directly here. That's what that magic this does. Hey Eric, thanks for coming, mate. And that invokes this, which means that we end up with our TLV dictionary being instantiated, okay? Now I'm creating an overloaded constructor that takes another parameter, which is a different type, and that does the same thing. It calls this base constructor over here so that the TLV dictionary is instantiated. And now we're about to provide some functionality that effectively does something very similar to this. Okay, so we may even refactor this in just a minute. Does that make sense? Hopefully that makes sense. And this is actually riddled all the way through the .NET framework, right? So for example, if we created a new memory stream, okay? So you can see we can create a memory stream like that. We can create a memory stream as is. We can also create a memory stream that takes, you see how there's 1 of 7? There's 7 overloads. So you can give it a buffer, which is just a collection of bytes. You can give it a capacity, so how big you want that memory stream to be. You can give it the buffer and whether you want the thing to be readable and writable, and so on and so forth. You'll see there is lots of different overloads there. So you can do the same thing in your code. Pardon me. Did we just have a new follow? I think we did. OXFed, thank you for the follow. Oh, and 3 hours ago there was someone who subscribed. Thank you, Takey Briz. Much appreciated for the sub. It's very, very kind of you. So what we need to be able to do when we're reading things off the stream, okay, we have a scenario where we effectively want to do the code, to do the same thing that we did before, where we created a packet based on our array of bytes. But we want to be able to read that array in. Now remember that when we're doing that, we need to be able to sort of pre-parse some of the bytes and detect how long the packet is, right? Another follow, Lapjaw, thank you for the follow. It's very kind of you. Okay, so what we need to do is we need to pull in the header size. So the whole header is that big, right? New to web dev and coding, just learning vanilla JS. Cool, man. It's, you know, it's not a bad place to start. If you're really interested in picking up on your coding skills, I'd recommend spending a bit of time with something that's strongly typed so that you spend more time with the compiler than the debugger. But learning to code is a good thing regardless of the language that you decide to go with. So good luck to you. Okay. Now, which language? That's borderline religious argument, but you know, if I was to tell you to go and learn a language, it would probably be one you've never heard of before, because I'm a bit of a functional programming purist. But I think you know, a good starting point these days would be something like C# or Golang. I would avoid dynamic languages like JavaScript, Python, Ruby, because they tend to teach very bad habits out of the box. But like I said, learning any language is better than learning no language at all. So don't think I'm being a jerk in that regard. But JavaScript, I know it's used everywhere, but it's a bit of a mess. Yeah, C# is a really good language to learn, to be honest. It's actually had a lot of thought go into its design. So, and when you've got people like Eric Meyer and Anders Hjelsberger, the people that are behind C#, you know that you're onto a better thing than a language that was made by a guy who had never built languages before and developed it in 2 weeks, which is Brendan Eich and the construction of JavaScript. Teaches you more than just code indentation. All right, so we know that when we're reading a packet off the wire, we're going to need to read in pretty much everything up to and including the length, right? So we know that there's 28 bytes, right? So what I'm going to do is I'm going to read the whole header in. So that's basically the whole header, okay? And we're going to go var header equals reader.read bytes. I'm probably going to create a constant here just to make this a little bit. Private const. Oh, I think I have to make it an int, don't I? Header size, which we know is 4 bytes for the XOR key, 16 bytes for the session GUID, 4 bytes for the encryption flags, 4 bytes for the length, and 4 bytes for, what was it? The type. Okay. I'm also going to go private const int offset to length equals, what is it? 1 to 24. Yeah. So let's leave that there for now. So we want to read the total number of bytes is the header size. Okay. So that will sit there and block at this point. Okay. You're welcome, mate. No problem at all. Anytime. So that's going to sit there and block until we've read the whole header in. But then once we've got that header, the first thing we're going to need to do is grab the XOR key, which is 4 bytes, right? So we'll get the XOR key, which is new byte 4. And then we're going to copy that XOR key out of the header. And we're going to put that in, can't type, put that in here. We've got to copy this out because we've got to use it. And we know it's going to be XOR key.length. Okay, so we take a copy of the XOR key. Next, I want to XOR the bytes in the header by using this XOR key. Okay. Now, what this means, sorry, ref header. You make so many less console write lines than I do. We don't actually have a console to write to at this point. We're sort of in abstract no man's land with no console attached. We're going to be even further from it very soon. So, all right, so we've XOR'd the header, which means all of the values are now effectively stripped out in the way that we want them to be. Okay. So what I'm going to do is just again to make this easier, I'm going to go using var header stream equals new memory stream, and we're going to give it the header, the DXOR'd header. I'm going to ask your opinion on something in just a minute. Okay, we'll do the same thing with the header reader, and here we're going to be going a new binary reader, header reader. Okay. Oops, not sorry, that's header stream. Brent, just wait until this is living inside of another managed process. Yeah, that's going to be great. Or even in a native process. We'll get to that well down the track. Okay, so what we're going to do now, because we've wrapped the whole header up, and the whole header is basically completely in the clear at this point. Now remember, we're not dealing with encryption flags at this stage. All we want to do is get the length and the type. Okay. So I've been running CLR instance implants the last year, way less complex than this. Well, you know, maybe that means we're doing it wrong. So we're going to go header reader dot base stream dot seek. We're going to go to offset length from seek origin dot begin. So we're just going to cruise straight to the length. I'm going to go var packet length equals header reader dot, what are we going to say, read, it's just a plain old int 32, isn't it? So that reads the packet length. Oh, I wouldn't say that, mate. Complexity comes at a cost, you know. You might add more features, but you may also add more instability or more bugs, etc. Okay, Savio, just give me a minute. I'm going to come back to your question. It's a good question. All right. I'll make sure that everyone else understands what's going on at the same time. Okay. But once we've read the packet length, we then know, because remember the packet length includes all of the stuff from the length and the type followed by everything else, right? So the packet length that we need to read, let's call it this, bytes to read equals header reader.read int 32, and we're going to subtract 8 because that includes the 4 bytes for the length and the 4 bytes for the type. Damn it, that's one question that I didn't ask Matt, and maybe I should ping him on Twitter or something and ask that question. So TLV packets are actually length, type, and value, and the length includes the 4 bytes for the length and the 4 bytes for the type, which are always there. And as a result of that, littered throughout MSF, you're constantly adding 8 or subtracting 8 in order to read more or less information. And it kind of drives me up the pole. So one thing that I should have asked him was, why is it that you included those fixed 8 bytes in the length when you're always adding and removing it? I know it's a first world problem, but you know, it is what it is. So next we need the body. All right, the body of the packet, no, let's call it packet body, equals, where are we? We want it as part of the wider scope, don't we? So let's perhaps do this here. Packet body equals default byte array. Oops. Okay. So then down here we can read the packet body out. We can go, what are we looking to do? Reader.readBytes, bytes to read. Okay. So that means down here we now have the whole packet read in. Go ahead and parse it. Okay, so but the thing is right now it's in 2 chunks. So there's no really nice way of just like concatenating arrays, I don't think. Yeah, it is. We seem to have managed to get onto Techno Jingle Bells again, haven't we? I could have sworn I got rid of this from my playlist. Just give me a sec. I'm going to skip it. It's bloody awful. Sorry about that. Hopefully this will be better. If it continues to play. Okay, so we've got the 2 chunks. We've got the header by itself, and we've got the body of the packet, right? What does the default on the byte array mean? Okay, so the default keyword here basically says apply what would be a reasonable default value based on this type, okay? So we could do something like var x equals default int, and that would probably be 0, okay? So that would effectively be the same as going like this, int y equals 0, okay? Now this packet body, I could do the same thing by going byte array. Crikey. Packet body equals null, because basically every reference type will be initialized to null, but I like to use the var keyword and let the compiler fill the gaps. Plus, if the default value of an entity changes from implementation to implementation, then you can rely on the fact that you can always refer to, you know, default and have sort of at least consistent behavior within a particular thing. So you can compare against default of a certain value if that's helpful. So yeah, it's like an initializer for the type. That's pretty much all it is. Okay, so let's get rid of those comments for now. In fact, I'm going to get rid of that comment now as well, because that's a little bit superfluous. So now remember, we have the header already. We've read the whole header in here. Are there any downfalls to making most variables generally just var? No, mate, not at all. It's just remember that, well, I guess there are cases where you might want to do it. And that could be to do with casting and making sure that, like, for example, you can do this, var x equals new memory stream, okay? But what you can also do is go I disposable y equals new memory stream, okay? So on X, the compiler knows that X is a memory stream and can do all of this other stuff, whereas Y can only dispose, okay? Because a memory stream is actually I disposable. So there are cases where you might want to do this so that you're effectively, is it upcasting or downcasting? I never remember the direction, but you're upcasting. You're casting up to the parent that you've inherited from. And there's uses for each of those things, depending on the scenario. Okay. Thankfully, in this particular case, yeah, it depends on the type, depends on your usage. Thankfully, in C# we don't have the issue that you would have when dealing with references in C++, particularly when it comes to catching exceptions and things like that. And that's like, I think they call it splicing or slicing. Class slicing. When you catch or you pass in an object of a certain type that's not by reference, then it actually takes, let's say you've got class A and class B inherits from class A, then you end up with this scenario where if you have a function that takes a class A instance and you pass in class B, then class B will actually get spliced into an A and copied because it's not by reference, and so you actually lose a bunch of B's functionality and data by doing that. And so if there's any virtual methods, then you end up with all kinds of crazy behavior happening. So it's one of those gotchas in C++, which I don't know whether they've fixed that. It's been a while since I've played in that space. But you don't have that in here, so that's a bit of a win. Okay, so like I said, we've got our header, and we've got our body. Now we effectively want to pass in the equivalent of this, right? Because all of this stuff we effectively want to copy or replicate. So how about we do, let's just see what that code does again for a minute. So that's just de-XORing everything. And we can probably change this to header size now, right? Because that's 28 bytes. Hang on a minute, we've got something wrong here. That's looking to read from the length, so no, I shouldn't get ahead of myself. Yeah, I'll leave that alone and we'll come back to it. Okay, so let's just, for now, just to get things moving, I'm going to quickly convert this that we've just written back into a blob of bytes that we can reuse. Okay, and I'm going to do that by going var, I'll call it data to keep it consistent with what we're going to be invoking, and this is going to be a new byte array, and it's going to be header.length plus, what's it called? Packet body.length. Okay. Now, because we took the header here and we XORed it, right? You can see we XORed the bytes. We ended up with a header that has been de-XORed while everything else has not been de-XORed. So we have to be conscious of that. And what I'm going to do is either take a copy or re-XOR it. I don't know whether is there a clone? Creates a shallow copy of the array. That's fine for us. We want to do this before. So we've read the header in. And we're going to go, I'll call this, we're going to chuck this away anyway, right? Cloned header is header.clone as byte array. Jeez, I can't type tonight. Okay, so then we can go ahead, and what we can do, instead of copying into the header, we can copy into the cloned header. And we're going to XOR the cloned header. All right. Why did I do that? It should be here, sorry. Cloned header. And then, if I could type, clone header, so read from there, and then here we can just have header length, packet body length, and we can combine the two, right? So array.copy, copy. We're going to copy from header into data, header.length, and then we're going to go array.copy into, from packet body. We're going to use a different overload here. So from the source, we're going to start at 0, and we're going to copy into the header, beginning at header.length, and for the total amount of packet body.length. At which point, we should be able to call, so here's we've got this packet, and we go parse data, and off it goes. So what I might do, instead of doing all of this magic with parse, we take, hang on, let me just make sure. Yeah, let's do this. I'm going to take this stuff out and shove it in parse data. Okay. This means that we can then just use exactly the same thing here after we've read it from the stream. Yeah? Does that make sense? Anyway, so once I've tested this, I want to go back and answer Savio's question, because I don't want them to think that they're being ignored, because it's certainly not being ignored. But we need to go into our transport, and basically we want to do this. Return, actually what we'll do is we'll make it temp, so our packet equals new packet, binary reader. So using var reader equals, we don't have a reader? We do have a reader, so we can do this dot reader, TCP reader. Okay, so we can just pass our reader down, and then we can return the packet. Okay, let's see what happens. Now, what I'm going to have to do, because we've actually rebuilt this DLL, we need to take a copy of it. Open containing folder, so bin, what are we doing? Debug. So we need to take a copy of this, and I need to dump this in Scratch. So with that out of the way, we can reference this from the other virtual machine. Okay, so I'm actually going to cheat here. Let's just exit out of this for a minute. CD data Meterpreter. Okay, so I'm going to remove star.dll. What I'm going to do is create a symbolic link. I don't even know whether this is going to work or not. To Scratch. Sorry, it's not there, is it? It's in mount HDFS Scratch Metserve. Alright, so there's a symbolic link there, which means I can just copy it over to that file share and everything would just wire up. At least that's the theory. Let's kick that MSF console up again. Whoops. And then we'll see what happens. Be exciting if this works. Okay. Run. Okay. So we're going to go and deserialize our packet. There's our TLV dictionary being instantiated. So let's read in the header. Header looks good. Take a copy of the header. Now this is important, right? Does the cloned header? Yep, it does. Excellent. That's what we want. Because basically what that means is we take a copy of the header and then we can XOR one of them to read data out of it, but then we don't need to re-XOR it again before we do our typical parsing. Okay, so let's take our XOR key out. So that should be the first 4 bytes, which looks good. And then we want to XOR the cloned header. So there should be a lot of zeros followed by some stuff. And we'll see what happens. Okay, so header reader. Now this is interesting, right? Oh yeah, this is a memory stream, so we're okay. So we read the number of bytes to read that's left. Oh, that doesn't look right, does it? That looks terrible. So clearly we've got this offset incorrect because the bytes that we've got left to read are way, way too big. Let's just have a quick look. So I would assume, hang on, header reader, header stream. Header stream is from the cloned header, which we have de-XORed. Ah! First of all, we need to read a D word. And that reads... So I think this offset is wrong. Offset to the length is wrong. So we've got XOR key, session GUID. So we've got 20, it's 24, not 28. Oh yeah, there you go. So it is 24. I'm going to go away to collect the order. You continue with everything. We'll catch up in a minute. Okay, mate. I'll wait. When you get back, let me know that you're back because I want to answer your question. I promise I will answer your question. Okay, so let's quickly run through this again and we'll get back to here. So let's clear all the other breakpoints. Build. What I might actually do is on successful build properties. This is quite handy, right? So build events, post build, edit post build. We can basically go, let's have a look. We want to get the full target. Here we go. So target path. We're going to go copy -y/y from target path to, what is it? Z scratch. All right, so if we look at this, you can see that it's 8:44 p.m. Now, if we do a successful rebuild of this, that's updated at 8:49. Cool. So now we don't even have to manually copy stuff. It'll just automatically wire up. So post-build events are really handy for that kind of thing. Go. All right. So a header reader is currently, pardon me, 18 bytes in. 18 hex. Let's get rid of the hex display. Base stream. Where was it? Yeah, so length is 32, position is 24, which is what I would expect, right? So then behind the scenes, non-public members, we want our buffer, which is 32 bytes. We're starting at 24, which is 1, 2, 3, 4. So we should be able to read that and it come out. That's a bit better, isn't it? So that's read in 539 bytes. So that means 539 plus whatever the header length is that we've read, because we've read the whole header in. And we've got 571 bytes. Concatenate the two together. Ooh, what happened there? Did something silly. We're getting close though. So header length and packet body. We're going to copy from the header into our array, header.length. And then what are we going to do? We're going to copy from, remember this should be the source array, yep, packet body. Starting at position 0 into, yeah, that's our problem. This shouldn't be header. It should be data, shouldn't it? That should be header.length still. There we go. Welcome back, Sphinx. Good to see you again. Savio's back with his chicken biryani. That sounds pretty good. This is still C#, Sphinx. Okay. So this should actually go ahead and do its shenanigans if I could set a breakpoint. Oh yeah, I need to build. Okay. There you go, that's better. And we should be able to parse and hopefully, check it out. Core negotiate. Look at this, that's awesome. Core negotiate TLV encryption. TLVs. So we've got a public key, and there's the public key. Look at that, we're actually talking to Metasploit now. We just read a packet off the wire and deserialized it into our TLV packet so that we can actually start talking TLV language. Method, core negotiate TLV encryption. Yeah. So that's pretty exciting. So there you go. So once we've got this packet, we then need to be able to dispatch the packet, which is kind of cool, right? So we can start working on a little dispatching dictionary, okay, which is, I think, pretty cool. Now, dispatching works in different ways in different implementations of Meterp, but I think for our needs to begin with, what we're going to do is we're going to focus on the core set of functionality that MetServe itself has to support. And then if we can't find whatever it is that we're looking for in there, we obviously need to fall back to looking at extensions. So I do have time to start the dispatcher. Yeah, I'm going to stop probably in about 15 minutes because I am pretty cooked. But this is cool, right? We've made some good progress already. I think we can put the basic dispatching code in place. Okay. So what we might do is have like a, I'm not going to call it a dispatch. I'm going to call it something more specific to like a packet dispatcher. But remember, we've got this plugin manager that we've already started working on. Okay. So every single one of these things, see how we've got this invoke handler? You give it a packet, and it tries to get a function definition out. So what we might do here with this plugin manager is actually not only register a function, but we'll register a core function, which I think will actually make the most sense. Let's have a look. Handlers, exe functions, etc. So what that means is, like, at the end of the day, the server is going to need to have a private plugin manager. Okay. I'm not going to make this visible to anything. It's going to be part of the server, right? Now, see how we've got this invoke handler? Now, the other day you were using Python. Now is C# with Metasploit. So I wasn't using Python. Yeah, Sphinx, I don't remember writing any Python. I was playing in Rubyland like we were earlier. We were mucking around on the MSF side in Rubyland. But I wasn't writing any Python, trust me. Okay. Sorry, I've lost where I was at now. Okay, we've just instantiated our plugin manager, and when we read in a packet, which is inside here, we want to be able to dispatch the packet, right? Oh yeah, I did use Python to dump packet data. So that, yes, correct. Thank you, Wolf, you are correct. I did have a Python console open. I was just using that for one-liners to be able to just pull data out of Metasploit and put it in a form that would allow us to bake it into our testing code here. But that has nothing to do with the core functionality that we're actually working on. Okay, so what we want to do then is inside our server, once we've got this packet, we want to be able to go, let's go, we'll call this the request, okay? So if we have a request, then we want to go this.pluginmanager.invoke handler, and we want to give it the request. Okay, that should give us a response. Oops. Okay, so we should get a response packet out of that. And if the response packet is effectively not blank, then we need to, let's go to this.currentTransport.send packet. Maybe I should not call it get packet. We should just call it receive packet, just to get our nomenclature or whatever it is correct. Receive packet. Do the same here. Okay. So then we need to be able to send a packet down the wire. Now this is probably going to change because remember, with our invocation of any handlers as part of our dispatch loop, some things actually need to be invoked on the primary thread and some need to be invoked on a secondary thread. Okay, so most of the commands that you do, like file listings and all that sort of stuff, they're going to get invoked on a secondary thread. But some other ones, which such as exit, like closing down, we want to actually run those on the current thread to see how they work. Now at the moment, you'll notice that what I've got is when we invoke the handler, we get a response. I will change this down the track, but for now, this I think makes sense to bring people up to speed with what it is that we're trying to do. Okay, so we need to define this method. Shouldn't have done that. Hang on. Undo that. Now we're going to send the response down the neck of the transport. So let's define that as a method on the interface. Okay. And then we can go to our HTTP transport and let's just implement that with a not implemented exception. And then with our TCP transport, we'll implement this, and this time we should actually be able to do something with it. Right? Now the difference being that, where are we? So we've got a packet that we want to send. Actually, I can get rid of this now. Let's go and do this. So response.toRaw. Now we've got to give it a session GUID, which means we need to bubble the session GUID down to whatever this function is. So we should probably pass in. We've got configuration that has the session GUID in it, don't we? Where is it? It's a session. So do we have a reference to the session in the transport? We probably should have one. Hey, let's have a look. Got transport config. Public void configure from binary reader. So you can see, because we have our session object here, right? So maybe for every single transport that we have, we should actually pass in a reference to our our session. So where's create transport? Where is it? Where is it? Where is it? Here we go. Load transports. New transport config reader. Create transport. Maybe we should give the session at this point, right? Because the transports need to get an idea of anything that's related to the current session, and that could be things like encryption keys and session GUIDs. So let's figure it out. Let's make that happen now. Session TCP transport. So we're giving it. We'll give it the session first, I think, and then we'll give it the configuration afterwards. Actually, no, let's not do it that way. Let's do it the other way around. Okay. So that would mean that I'm going to force this to be the case by... We'll end up moving down the path, I think, at some point that Mongo alluded to a few streams ago. We will probably use an abstract class rather than an interface, but for now this will serve its purpose. Okay, so TCP transport config. Okay, this dot session equals session. Now we don't need to expose this, so we'll just have a field. And we'll do the same on the HTTP. And you see we're actually got a bit of code duplication going on now, which means this is something that we'll have to refactor, but for now, this will work. Okay. Alrighty. Right. So with the session already in place, then we can go to raw this.session dot session GUID, because that's where it lives. All right. Var raw packet equals. So that's serialized our packet. And now we should literally be able to go this.tcp. Let's have a look. I've got the stream. So we need to actually have a writing stream as well as a reading stream, don't we? So, there you go. The network stream is the stream. So TCP stream dot, can we write? Here we go. We can write the raw packet at 0 raw packet dot size length. There we go. Okay. So the general flow here is, in our server, we are going to, like I said, this is right now, but we're probably going to change some of these things up. So once we've got a valid transport, we are going to, this is basically where our dispatch loop happens to be. Okay. So here we're checking to make sure that we haven't expired, and make sure the transport retry has not expired. Okay, so at this point we know that the transport's connected. Okay, so what we need to be able to do is we need to have like an inner loop. Okay, and we're not going to do this right now. We'll do this probably on the next stream. We need an inner loop. Now we've got a valid transport. We want to be able to sit there and just dispatch on that transport. So what we'll probably end up doing here is moving this into a separate function. And for now, I'm just going to go private void dispatch. We'll go packet dispatch loop. We'll just call it that for now. And this will, again, this will change. Fat fingered again. Now, this is actually a little bit messy because everything's referenced off the current transport, but that's okay for now. And like I said, we are going to be changing this. Okay. So basically what this means is we're going to loop while true in the same way that we did before. Okay. So if we try and read something and we don't get it, we should probably bail out of the current transport. Okay? Which means all we have to do here is break out of the loop. Now what we should do is go to the next transport. Why are you using var instead of reference type name? Because I prefer it. And I don't want to have to type it every single time. I want the compiler to do it for me. So receive packet returns a packet instance, but I might not know the type that a function is returning. I might not know the type of the variable off the top of my head, so I much prefer the use of var because the compiler will tell me what type it is. Or IntelliSense will tell me what type it is. Okay, so we'll leave it at this for now. Okay, so if that breaks, then we bail out. Otherwise, we loop. Okay? And then here we're just going to go packet dispatch loop. Why did it not capture where I wanted to be? Let's just rebuild. Okay, is it connected? Yes. Oh, it's because I don't know what I did. All right, so can we get a request packet? Yes, we got a request packet off the wire. There it is. Now, you'll notice here that when we try and pull out a function definition, it doesn't exist. So we don't actually have a handler for this particular method just yet, okay? That's something that we need to implement. And this isn't something that I'm not going to implement on this stream. So isn't the var thing a way of saying to C# that we support dynamically typed variable? No, it's still compile time. It's definitely not done at runtime. The var keyword is something that's handled by the compiler. It's not something that's handled by the runtime as things are executed, okay? And let me just demonstrate that for you. So you see how var request is current transport receive packet. You see IntelliSense there says that we're expecting a proto.packet in response. So I should be able to go request dot, and you can see I can use IntelliSense to look at all the elements that are on a request object, which is of type packet, okay? So this is functionally the same at compile time as me doing this. Exactly the same. It's just that I am letting the compiler handle that for me. Barney! You're a crazy man. You're a crazy man, Barney. Good to see you, mate. All right, so let's quickly get back to Savio's question. Bit of confusion. When we get the type from the network stream, did we create the type from metserve DLL? In that case, the DLL should have namespace metacall.server, isn't it? Or we are creating a type from our new project and not from DLL content. Confusion is that the new project will run on victim machine. Did we address how this code will be delivered, like an initialized stage or loader? Otherwise, the whole assembly loader doesn't make sense. All right, so that's a little roundabout, but let me just quickly recap to make it very clear. So you'll see these two projects that we've got sitting here on the right-hand side. This console here is just a blob of code that I'm using to throw bits of crap together so that we can validate that things are behaving themselves, okay? Now, metserve.net 3.5 is a DLL, as you can see, right? And that is when we build, we're just copying it across to another virtual machine. And that is wired into Metasploit. So this metserve.net 3.5.dll is the stage. It is the core of metserve, and that is what's sent along the wire when we first kick this off, okay? So what I've got here in my test console app, you'll see, I have no references to Meterpreter. I have no references to that project. You can see that there are no references other than the ones that come with .NET, okay? So this means that test console.net 3.5, this project here has literally no idea about anything that's related to what's in this, okay? But as you can see, what we're doing here is when we run this test, we are opening a TCP client and we're connecting back to our Metasploit listener, right? So you can see here, you watch, when we connect, here we go, we're sending a stage. So that's us connecting back to the Metasploit listener, and the stage is 30787 bytes. So let's just quickly check this. Let's have a look. Oh, see, it's not even caught up. So it's not got the same amount. Okay. That's probably me being a doofus rebuild solution. Oh, hang on. No, that's not me being a doofus. Let me do that again. Righto, so we come back over here. You can see we are sending 30787. That is a combination of two things. It includes the DLL, which we've got sitting on disk here, and that DLL is of size, whatever it was, 29696, plus a configuration block, okay? So that is sent down as a block down the wire, okay? So we connect, we grab the TCP stream, and we read the size off the wire, 30787, okay? Then we read everything else in. So there are all the bytes, okay? And then from there, we are reading in the size of the DLL itself. So metserv is 29696, which we've already confirmed is that, okay? And then we skip past that. We load the assembly using reflection. Okay, load the assembly using reflection. That's just literally .NET looking at that stream of bytes and saying, no problem, I'm going to load that in and wire in all of the types that lie inside it. Okay, which we know one of the types is met.core.server, and it has Bootstrap functions. One that takes a binary reader, one that takes a binary reader and a TCP client. Okay, and here we're getting a reference to the type using assembly.getType, and then we're calling invoke member, a member called Bootstrap, which is the name of the function we want to invoke, and it's a public static function, and these are the parameters that we want to give it, right? So when we step in, we can see that our metserv, which has come down across the wire, so that's the first stage, has now taken over, okay? And then from here we should be able to get to the packet dispatch loop, right? Receive a packet, try and generate a response, but we don't have one. So does that answer your question, Savio? So we are aware of literally two things in our stager. So this is effectively what a stager is going to look like, or something similar to this. The stager only needs to know, first of all, that met.core.server exists inside metserv, and that the function called Bootstrap exists inside it as well. And then from there, you basically create an instance by invoking that Bootstrap function, just saying, off you go. All right? So that's effectively what I mean. Yeah, no worries, man. I'm glad that cleared things up. So at this point, it's 9:15. I would love to go through and quickly implement a very simple packet handler for the encryption function, but we're going to do that on the next stream. I'm going to be a good boy, and I'm going to put it on ice, and I'm going to start the upload process and all that sort of stuff, so you guys can read that. But I'm hoping that you got something out of tonight's stream. It's good to see. Like, anyone else excited that we're actually starting to talk to Metasploit? Because I am. And what we're going to do probably over the next stream as well is readjust some of the setup we've got here, because I think we really need to unbind our dependency on Windows. So if you can see here, like we are Windows CLR Meterpreter. I'm going to get rid of this Windows dependency thing. It should just be CLR Meterpreter reverse TCP, in the same way that it's like Python Meterpreter reverse TCP. The fact that it runs on Windows at the end of the day really isn't our concern. Okay, so with that, I'm going to look to wind things up. As always, I'm very grateful for everyone's attendance, particularly on a Friday night Australian time, and enjoy your respective weekends. Now, what I will say too is there's a bunch of crazy stuff going on next week. So I'm sorry, mate. I'm going to get this going. I'm going to go and hang with my wife, who is lovely and deserving of some time. And so anyway, on Monday, I'm not going to be able to stream. I'm going to be in Sydney for the day, but I should be able to do it Wednesday. There's a chance that I might not, because my wife and son are heading to Sydney on Thursday early, and my son's competing in the Australian National Climbing Competition, which is pretty exciting. So next week might be a bit turbulent with the amount of streaming that we're going to get done, but I might try and compensate with that by doing some streams during the day, in whatever gaps I can find. So, and answer your phone, man. I tried calling you back today, Barney. I tried calling you back. All right, people. That is it. That is time. Thank you so much. Much appreciated. You're all awesome, and be kind to each other. See ya.